That is where we are ending. We'll come and finish it on Wednesday. So let me just welcome anyone who will find this video that we are making. It's a video on errors in a Zambian mathematics papers. We've got a topic called errors, but if you use books like Progress, Longman, it will be written approximations and estimations, or just approximations. So with me, I have Madam Jane and I have another lady called Selina. So they are my respondents for today. So ngawa blaka nstwa blaka bonse pamo, and we will be corrected together. So let's begin. When you hear errors, ladies, what comes in mind? Madam Jane. Ngamwamfat errors. What comes in mind?
It's mistakes.
Okay.
Mistakes, yeah. So in accounts, usually what we say, instead of you, let's say maybe the figure you're supposed to enter it's 20. Instead of you putting in 20, you put in 10.
Okay.
Yeah.
I have interest in studying accounts in the near future, so I'm sure I'll find that as I do accounts muntansh. Madam Selina, what's for you in terms of errors? What comes in mind?
I equally think of the word mistakes.
Mistakes. Okay. Yeah, that is okay. But in mathematics, errors, we don't say mistakes. No. We say errors are degrees of accuracy. Errors are what? Degrees of what? Accuracy. Errors are degrees of accuracy. They will just show you how far you were from the answer, or how close you were to find an answer, or yeah, in those terms. But I am repeating, for the sake of understanding, I might use mistakes as we go on, just for the sake of understanding. But in mathematics, I am repeating, we don't say errors are mistakes, errors are degrees of accuracy. So I want you to look at this an example. Let's look at an example. Look at this line. Let me draw it in red or blue. Line A, B, in. Are we there? Let's say line AB has been measured to be 4 centimeters. Like that's the actual length. Actual length of this line AB is equals to this line AB, it is equals to 4 centimeters. Just give me a minute. 4 centimeters. And then now, you, Madam Jane, you have been told to measure this length with a ruler. Okay? And then you find something like 5.6 centimeters. Okay? We give Madam Madam Selina to measure the same. She finds 3.8. centimeters. You can start. You find 3.8 centimeters. So the question I have for you, who is wrong, who is correct? Mwalala?
We're here. Me, I will go with 3.3 at least it's near to 4 centimeters.
Madam Serena?
Both are wrong.
Both are wrong. So, both of the answers are, they are not wrong. Okay? Both of the answers are not wrong. They just have errors. Because you haven't found exact the same as 4 centimeters. Why? Because of the instruments that you've used. Maybe the ruler was not put accurately on the numbers. Maybe the ruler was broken, or maybe the calibrations were not done properly. So what causes errors? My instruments to go on fear. Okay? But do you know that if we are to round off, okay, except for this one, if we are to round off, this one will be near to the answer. This one will be 5, this one will be 4. So you are very close, Madam Jane, when you said AB on the second one, which we had assigned to Madam Serena, would be close to the answer. So you've seen that the first one has the error is very much. It's too big. Are you following? The first one.
Yes.
The second one, the error is very minimal. So if they were to mark this, I think it would be sender number 2. Okay? There is what is called tolerance as we go on. Tolerance. The error that you can allow to say, okay, fine, we'll take this guy is close to the answer. But some tolerance is just too much. You can't allow an error. It's chocolate. Okay? So that's what we'll be dealing with due to other people who find this video. I will be addressing, ladies and gentlemen. So this is these are the things that we'll be dealing with. So we can find the error in these things. Okay? So let me actually give you the formulas for finding error. So now there are a lot of formulas to master here. Formulas.
This one comes under
Paper 1. It's paper 1. Today it's paper 1. Remember, Monday paper 1, Tuesday paper 2, Wednesday paper 1, Thursday paper 2. So the first formula, it's called absolute error. Absolute what? Error. You say absolute error is equals to, you draw this one. Absolute error. You say, sometimes I swap them, but I hope I will not be able to swap today. Absolute error. Let me just confirm with me in progress. I have progress on my phone right now. Let me just confirm something under progress. I normally swap on actual value minus measured value. Actual value minus measured value. Progress. Okay, I found it. It is here. Okay. It is actually the first topic. So those who have Zambian syllabus, it's the first topic, approximations. The first topic. So it is here. Okay, so absolute error, it's recorded value minus true value. Yes, that's what I normally swap. So Mama Natama teachers, they are just human beings like you people. Sometimes naife tulalava, sometimes tulapanga mistakes. So here we are writing to say recorded value minus true value. I'm using shortcut. I don't have enough space. So that is how you find the absolute error. Absolute error, you can find it by having recorded value minus true value. Are you there? Now, when do you use absolute error? When do you use this formula? By the way, these two symbols means modular sign. Modulus means the answer should come out positive. Even if the inside you've got -2, don't write -2, you have to write +2. That's what these symbols means. They mean, can you change the negative into a what? Positive. So there is no negative answer under absolute error. It's always positive. So when there's a negative inside, change it to a positive. Now, when do you use this formula? You can write somewhere to say this formula is used when you have two values in the question. When you have how many? Two values in the question. That's when you use this formula. There are times when you only are given one number, one value in the question. You say absolute error, it is equals to n over 2. So when you're only given one value, one in the question, you have to say absolute error or just error. If you want, you can just say error is equals to n over 2 or just absolute error. Either way is okay. The n, write somewhere to say it stands for unity difference. It stands for unit difference. That's what the n is for. We shall get to know what is it, how is a unit difference. But it's a unit difference between from one number to another number. Did you catch that?
Yes.
The other formula to master, it's what is called relative error. Relative what? Error. Okay? Relative error is found by you saying absolute error over true value. That's all. You just have to divide the error that you have found, called absolute error, divided by the true value. That is all. Did you get that? When they ask you to find the relative error, can you divide the error that is in the measurement divided by the true value? That's all. There's what is called percentage error. Percentage what?
Percentage error.
You just have to say percentage error is equals to absolute error over true value times 100%. Or percentage error is equals to relative error times 100%. So you can use any. Percentage error is equals to absolute error over true value times 100%, or relative error times 100%. Very straightforward. Did you get that?
Yes.
There is what is called maximum length or maximum measurement. They can ask you to find maximum measurement, okay? Or upper limit. The upper part of a measurement is called the upper limit or maximum measurement. You simply say true value plus error. The error is the absolute error or the error, yeah, whichever error you found, whether for two values or one value, whatever error is found, when you add it to the original true value, you are going to find what is called upper limit or maximum measurement. So in case I ask you to find maximum length, upper limit, you use that formula. Did you get that? The other one, two more to go, is called lower limit. Lower limit or minimum length. Lower limit or minimum length. Minimum length. Minimum length, minimum measurement, all those language can be used. You simply say true value minus error. That's all. When they ask you to find the lower limit or the minimum length or minimum measurement, minimum mass, minimum, if it depends on if but as long as it's minimum measurement, you have to subtract the error from the true value. Last but not the least, ladies and gentlemen, for the sake of those who find the video, it is called tolerance. Tolerance is the degree of allowance of the error. So tolerance, like our former president in Zambia, Edgar Chagwa was very tolerant, meaning he was allowing if landa criticism kumutendeka. Are you getting the idea? So tolerance is allowing. How far can you go in allowing something? Okay. Baba body tolerance. Okay. So even in mathematics, we have tolerance. Yes, you can make the so-called mistake, but in mathematics, we'll say you can make an error. But how far can we allow? What's a tolerance? There are some errors we can allow. There are some that we can't allow. They are too much. Imagine we are finding an angle 24 degrees. Imwango ni about 280 degrees. How? The tolerance is yakana. So tolerance, it's the error that is allowed for the measurement. So how do you find tolerance? It is upper limit minus lower limit. That's how you find tolerance. The upper limit, the answer that you had found, minus the lower limit that you had found. You subtract them, it will give you tolerance. It's usually very small, 1 point, 0 point, something like that. So that's the tolerance that is allowed. That's all. End of topic.
This question is how many marks?
It's 4 marks.
Okay.
Yes. So
It comes under question 1. Maybe we can try
Let me screenshot the questions for you. So let me also display the questions for those who are in a Zambian setup, paper 1, so that you see how the questions appear. Just a minute. Paper 1. They come in paper 1. So we started 2021. They're still bringing these things. So let's just wait for this to close up. Yeah, ladies, are we there? It's so I've opened I've opened 20. I have opened 2021 November. It came on question. I'm still scrolling down here. Question 12. They just gave one measurement. They actually gave two. It says, you can even write this one. A learner measured the length of a line to be 2.2 centimeters. A learner measured the length of a line to be 2.2 centimeters. You are there? Hello?
To be what?
2.2 centimeters. If the actual length is 2 centimeters, find the A absolute error. Okay. If the actual length is 2 centimeters, find find A absolute error, B percentage error. We can do that. We can do that. Just a matter of applying the formulas. Let me check in 2021 GCE. So let's just wait for this MadVet to go. Okay, they have gone. Okay, if I keep scrolling down here, it came on question. There's question 12B. Actually, 12A and B. 12A. Question 12. Hey, it's like it's a sequence, same question. Question 12. So, I'll just screenshot for you and send for you in the group. But take note, 2021 paper 1 GC question 12A and B. And then for those who are watching this video, you have to try those things. Let me also do 2020 paper 1 GCE. Zambian betting. These are two betting. Wait, if I'm betting. So, my mwana sequence again, question 12. I'll just scroll to question 12. Unfortunately, it did not come on question 12. Okay. It came on question 15. I also screenshot question 15. That question. Okay, lastly, maybe 2019 paper 1. Otherwise, fingy.
There's no, so for example, the absolute error for the first question we're trying. So it just say 2.0. There's no centimeter or what.
You add the units given according to the question. Wow, I found a very good question. I found a very good question in 2019. This one is short. You can write it. It's very short. We are there. The question, that is 2019 paper 1 November. The question says okay. Okay, let me screenshot. Yeah. Okay, ladies, so try those things. Tomorrow we are also starting section B, paper 2. So I'll need this to comment on tomorrow. So have a good night. We shall meet again.
Thank you.
Okay, thank you.
Good night.
Good night. Okay, so the class is done. Madam Chen, you've logged out? So okay, so everybody has logged out. I'm just remaining with now answering those questions so that you can see what is supposed to be done. So the first year, if you were following, it said so remember I mentioned that you only have two ways. It's either they give you two numbers or they give you one number. So in 2021, that first paper that I showed you, we were given that the recorded value is 2.2. Then the actual value, which is the true value, it is 2. So they said question A was saying, can we find the absolute error? We know that the absolute error is recorded value minus true value. So absolute error, recorded value is 2.2, true value is 2. So there are no calculators here. You subtract 2.2 with 2. So here it is, so there's a 2 here with a 0. So here it's a 2, so it's 0.2. As you can see, everything should come out positive, so the answer is just 0.2. That's our absolute error centimeters. Then the second question says, find the relative error. So the relative error is simply absolute error over true value. If it's percentage error, we could have said times 100%, but it's not that way. Absolute error, our relative error is equal to our absolute error here is 0.2. True value is 2. So this into this, it's not possible. Okay, you can't divide a big number like this into a decimal like this. No. So you have to first deal with the decimal. You have to first deal with the decimal. You say times. There's only one place value, so we use 10. If you've got two numbers, 100. Three numbers, 1000. Just like that. In this case, we're only using 10. Even at the bottom, you have to use the same number, 10. we have to use it 10. So if we multiply now, 0.2 times 10, it will just give you 2. 2 times 10 to give you 20. So 2 there, once. 2 here, 10. So the relative error is simply 1/10. That is done. That's all for that question. The last question for tonight, or for this morning, or for this afternoon, for this evening, it is this one. I'm doing question 13 for this 2019 paper 1 GCE. There are two questions, A and B. Question A is saying the mass of M of a block of wood is 876.4 grams. Correct one decimal place. Complete the statement in the answer space below. Okay, so how is this supposed to be dealt with? So this is 876.4. So let me go back to my solving board. So we've been given that we have to complete this statement, which says here, and the number that we've been given is 876.4 grams. So whenever you see such arrangement with the less or equal to, with this, the less or equal to, less or equal to, it means they want you to find minimum value, maximum value. Very straightforward. How do we do so? You remember, you have to find your upper limit and lower limit. Simple. So we have to start with the lower limit. You have to start with lower limit. Lower limit. How do you find lower limit? You say the measurement given minus error. Okay? You'll be this side? Not this side. The measurement given minus the error. So we are given this measurement, which is 876.4. Really? Come on. This is sorry, I had lost contact. So what we have is 876.4. Like I was saying, we had something like this. Less or equal to M, less or equal to. So we said we are finding our lower limit, where we are saying we need to subtract what we are given, 876.4 minus error. Now, what is our error? Remember what I said, that in this case, you only have one figure. When you only have one figure, you say error is equals to n minus 2. So this n, it is a unit difference. The unit difference for this figure, which is a 0.4, the unit difference for one decimal value, one decimal number, the unit difference is 0.1, sorry. When you've got two decimal places, your unit difference n is 0.01. When you've got 3, it is 0.001, just like that. So more, it's like you're following zeros. When you've got one decimal, you've got 1 0. When you've got 2 decimal, you've got 2 zeros, 3, just like that. When the number has no decimals, your unit difference is 1. Okay? Your unit difference is 1. Yeah, so if it is just 20 centimeters, it means your n is equals to 1. So please, in this case, we only have 1 decimal place. So our unit difference is, when there is 1 decimal place, even your unit difference will also have a decimal place, but just 1. So meaning we are now saying our error, we are now saying our error is our error is 0.1 divided by 2. Okay. So we are having here, I will just use the crook method. 2 into this, it's 0. 2 into 1, it can't. You write 0, you add a 0. So you'll say 2 into 1, it can't. You write 0, you add a 0 here. It becomes 10. 2 into 10, it's a 5. So that's your error. Okay. Where did the 0.1 came from? From here. You've got 1 decimal, so you've got 0.1. If you've got 2 decimals, 0.01. Just like that. So here, ladies and gentlemen, you are saying this side you have to say 876.4 minus 0.05. On the other side, you have to add, because it's upper limit, 876.4 plus 0.05. When you add, it will give this side. When you subtract this side, subtract nicely without a calculator, it will give you 876.35. Here to give you 876.45 grams, also grams. That's all. That's how you complete this statement. Okay, ladies and gentlemen, I'm ending on the last one, which is question B. They are saying the length of wire is 5.2 centimeters. Correct 1 decimal place. What is the relative error of the length of the piece of wire? So 5.2. So I'm erasing this. Question B is totally different from question A. So they are looking for relative error. We know that our relative error is absolute error over true value. So we only have one figure here. Remember what I mentioned about one figure? You only have one figure. So when you have got one figure, your absolute error is simply n over 2. That's all. N over 2. And your n is a unit difference. You've got one figure here, 1 decimal place. So your unit difference is 0.1. I mentioned when you've got 1 decimal place, your unit difference is 0.1. When you've got 2, 0.01. So your error here is this into this, it's 0. This into this, it can't, 0, add a 0. This into this, a 5. So that's your absolute error. So we are not saying your absolute error is always 0.05. It depends with your unit difference here. So you've got So now that we know our, so I can write properly 0.05 over 15.2. We can't divide, we have to multiply. On top we've got 2, we use 100. If you've got 1, you use 10. Same numbers at the bottom. So you just cancel this 0, cancel this 0. 1 times 5 to just give you 5. Here you just cancel like a 0, cancel the decimal. So now multiply 152 times 10 to give you 152, 0. 5 into 5, 1. Or you can write it inside 1 over 5 into 15, it is a 3. This number is in thousand. This number is in thousand. So 5 into 5, it's 1. If you say, look at this, 5 into 5, 1. If you say 5 into 24, this will become wrong because this is 1520. And 5 can't enter 1520 34 times. It's too little. So the best way is to do this. You say 5 into 5, 1. You say 5 into 5, 1. 5 into 15, 3. Remainder 0. You write it there. Then 5 into 24. So meaning to give you, if you use a calculator, 5 into 1520 to give you 1304. So we end here. Whichever year that you are in, I've tried now 2017, try 2016, try 2022, try 2023, try 2025, try 2050 paper, 3040, try. Hey, until Jesus now, I'm sure now where Jesus is back here. So try maybe 9020, whichever year that you are in. Please, can you solve past paper questions from 2016 October up to date? I don't know which year that you are in, but as this video was made in 2023, so if it's a 24 that you are watching, please watch. Yeah, even including my children, Venabuseko, Venabukata, Agnes, and others that I haven't mentioned. If you are there, do them. Do questions in your year. So we are done. I'm Teacher Mvanga. Others know me as Professor. Prof. Mvanga. Yes, I work at Bukanzi Academy as a tutor. Bukanzi Academy. Yes, so I spearhead this group of Bukanzi tutors. That's where we are. In case you are in Zambia and you want to contact us, you can use this number 0971 21 6162 for both online classes, physical classes. You can contact us on that number or 0968 11 0968 11 5110. Those are the numbers you can use. Shalom, shalom. Till next time.